I want you to do something for a second. Just take a look at the device you are using to listen to this right now.
Yeah, your phone, your laptop, or, your wireless headphones.
Right. There is this invisible magic making that device work, allowing it to process information or connect to a satellite. But what you are actually holding in your hand, what you're looking at, is a piece of a massive, high-stakes global chess game.
It really is. I mean, it is the defining geopolitical battleground of the 21st century. And it's just, hiding right there in your pocket.
Welcome to the deep dive. So today, we are functioning as your strategic war room. We're looking at India's rare earth mission, specifically the 2025 National Critical Mineral Mission, or NCMM.
Right, the big one.
Yeah. The source material we have today really gets into the weeds on India's strategic frameworks, the multi-billion rupee budgets, and, frankly, the incredibly harsh, toxic realities of global mineral supply chains. So our mission for this briefing, we need to understand why just 17 metallic elements are quietly dictating the future of national security, the green energy transition, and global economics. And how India is scrambling to secure its own supply before it's too late.
Exactly. And to really understand this issue, you cannot look at the technology in a vacuum.
Yeah.
If you're mapping this out analytically, you have to see how national security, economic independence, and climate resilience are all completely interwoven here.
Yeah.
Because this is not just about mining dirt. It is about a fundamental shift towards strategic autonomy. A country without these materials is, well, essentially at the mercy of the countries that do have them.
Okay, let's unpack this structural problem, because before we get into India's massive counter strategy, we really need to understand the threat level.
Right.
We're talking about rare earth elements, or REs.
Yeah.
This is a group of 17 metallic elements that are absolutely vital for advanced tech. Now, despite the name, they aren't actually that rare in the Earth's crust.
No, not at all.
In fact, India actually has some of the world's largest reserves sitting right there in the ground. So here's the obvious question. If we have the dirt, how are we facing such a massive strategic vulnerability?
Well, because having the reserves in the ground is completely meaningless if you can't process them.
Okay.
The trigger event for all of this policy action, and this is a key data anchor you need to remember, is China's absolute stranglehold on the global market. The numbers are just staggering.
Yeah, lay them out.
China controls around 60% of global REE production. That's the raw mining. But the terrifying number for policymakers, the real bottleneck, is the processing. China controls anywhere from 85 to 92% of the global processing capacity.
Oh, wow. So almost all of it.
Almost all of it.
I've always struggled with this specific part, though. Why is processing such a massive bottleneck? Like, if you can dig the rock up, why is it so hard to just build a factory and process it domestically?
Because extracting rare earths is not like panning for gold nuggets. You can't just sift it out. These 17 elements are chemically almost identical to one another.
Okay.
They clump together in the ore. So separating them isn't a mechanical process. It's an intensely complex chemical one.
Give me a visual here. Like, how hard are we actually talking?
Okay. Imagine you have an Olympic-sized swimming pool full of green paint.
Right.
And your job is to extract a single drop of blue paint that was mixed into it. And the only way to do that is to basically boil the entire swimming pool in toxic acid over and over through hundreds of sequential solvent extraction baths just to separate one element from another.
Wait, really? Hundreds of baths?
Hundreds. It requires massive industrial infrastructure, brutal chemical processing, and it generates a staggering amount of highly toxic waste.
Okay, that changes the picture completely. It's an analogy I like to use. It's like having all the ingredients for a cake sitting in your pantry, but only one guy in the entire neighborhood owns an oven, and he just tripled the price to use it.
That is exactly it. What's fascinating here is that China didn't just build a monopoly by having the most rocks. They built a monopoly by being willing to build those massive chemical baths and, absorb that massive environmental cost over the last few decades.
Well, the rest of the world was perfectly happy to offshore the dirty work.
Right. Everyone just looked the other way. And that is the exact mechanism of the monopoly. So what happens when one nation controls the bottleneck? They control the global economy.
Yeah.
Recently, China imposed export curbs on these elements. They just tightened the taps slightly, and the global market felt the shockwaves instantly. Global REE prices surged by 35 to 40% almost overnight.
Which instantly hits the consumer. I mean, the source notes that this specific price surge pushed up input costs for electronics by 20 to 25%.
Yes.
That is a massive inflation spike, purely dictated by one nation's export policy. It's essentially a geopolitical chokehold.
And that price spike is exactly why governments around the world are panicking right now. It exposes a fatal vulnerability in national security. Think about it. If your entire tech sector, your telecommunications, your digital infrastructure, if all of that relies on materials processed by a single geopolitical rival, your economic security is highly compromised.
You are one export ban away from your manufacturing sector grinding to a halt.
Exactly.
So that looming threat is the catalyst. The crushing reality of that monopoly is exactly what triggered India's massive government response, which brings us to the core policy framework, the 2025 National Critical Mineral Mission.
Right, the NCMM.
This is India deciding they need to build their own processing infrastructure no matter the cost. And looking at the numbers from a policy perspective, the cost is incredibly steep. We're looking at a total NCMM budget of 16,300 crore rupees.
Yep.
Is throwing 16,000 crore at this enough to just, magically create an Bar supply chain?
Well, money alone doesn't solve it. But that 16,300 crore is the financial anchor of a very calculated policy. What matters, and this is crucial if you're analyzing governance reform, is how the budget is distributed.
Okay.
It targets the entire value chain. So exploration, mining, processing, and recycling. It's a total ecosystem approach because, as we established with a blue paint analogy, fixing just the mining part doesn't break the monopoly.
Here's where it gets really interesting, though. Let's follow the money, because the allocations are super revealing. Almost half of that total budget, 7,350 crore, is dedicated to a production-linked incentive, or PLI scheme.
Yes, a massive chunk.
But this isn't for mining. This is specifically to incentivize the domestic manufacturing of rare earth permanent magnets, with a target to massively increase production capacity by 2030. Why the hyper-focus on magnets?
Because permanent magnets are the end-use bottleneck. You don't just put raw rare earth oxides into a Tesla or a fighter jet. You have to turn them into specialized alloys and then into high-performance permanent magnets, specifically neodymium magnets. These are the components that actually make the motors turn and the sensors work.
So by dedicating half the budget to the magnet PLI scheme, India is trying to pull the entire supply chain into existence by creating massive domestic demand for the finished product.
Precisely.
Yeah.
It's an aggressive demand-side push.
Sort of a build the roof and the walls will follow approach. Meanwhile, to actually get the raw materials, the Geological Survey of India is being tasked with 1,200 exploration projects by 2030-31. Plus, over 100 critical mineral blocks are going to be auctioned off.
And they are also pushing major institutional reforms to back this up. They're setting up centers of excellence for research, streamlining regulations to create fast-track approvals.
Which is huge.
Yeah, and simplifying licensing to actually get private companies to take on the risk of these massive projects. They are even actively supporting Indian companies to go out and acquire critical mineral assets abroad, in places like Australia or Africa, just to diversify the raw material source.
Okay, I want to stop on one specific part of this budget that really confused me at first. The stockpiling.
Oh, yeah.
The policy outlines 500 crore rupees to create a 2-month strategic stockpile of critical minerals to safeguard against supply disruptions. Now, I understand stockpiling oil in massive underground reserves. I understand grain silos. But stockpiling minerals for tech?
Sounds counterintuitive, right?
Yeah. How does a government practically sit on a 2-month reserve of futuristic metals? The technology changes so fast, how do you even know what to stockpile?
It is a logistical nightmare, frankly. You don't stockpile the final iPhones or the final missiles. You stockpile the intermediate materials,
Yeah.
the processed oxides, and the raw magnet alloys.
Okay.
But even then, physically storing enough of it safely is incredibly difficult and expensive, which is why you have to look at the other major financial pillar of this mission to see how they actually plan to achieve a strategic buffer.
What's the other pillar?
Beyond the mining and stockpiling budget, there is a separate 1,500 crore rupee incentive scheme, specifically for processing and recycling end-of-life products.
Oh, wow. So recycling is basically a backdoor to building the stockpile.
Exactly. You don't just try to hoard raw ore in a warehouse. By incentivizing the extraction of REEs from discarded electronics, E-Waste India is effectively creating an above-ground mine.
That's a great way to frame it.
This 1,500 crore recycling push is fundamentally about circular economy resilience. If external supply lines from China are suddenly cut, the domestic tech and defense sectors can theoretically survive on recycled inventory and strategic reserves, while domestic mining scrambles to ramp up.
Okay, so We know the budget, we know the plan, and we know they desperately want to build these permanent magnets. But I want to really dig into why these specific metals are worth 16,300 crore rupees to the government. The source uses this incredible metaphor. It says REEs are the specialized fuel cells and sophisticated armor of the future economy and
I
military.
love that phrasing. It captures the dual-use nature of these elements perfectly. We are talking about absolute technological power here.
Break that down for me.
Sure. On one hand, you have the green energy transition.
Yeah.
REEs are the non-negotiable backbone of electric vehicles, wind turbines, and solar panels. Without them, India's climate goals and net zero commitments are physically impossible to meet.
Right, because of those permanent magnets. You need intense magnetic strength to spin a massive wind turbine efficiently, or to make an EV motor compact enough to fit in a car but powerful enough to propel it at highway speeds. I read that conventional iron or ferrite magnets simply cannot replicate that intense magnetic strength at that size.
They can't even come close.
But the other side of that dual-use coin is defense. And this is where the sophisticated armor part comes in. We are talking about missile guidance systems, sonar, radar, satellite communications, fighter jets. But I need you to explain the mechanics of this. I understand a magnet in a wind turbine. What exactly is a rare earth element doing in a fighter jet or a missile?
If we connect this to the bigger picture of modern warfare, think about the extreme environment these systems operate in. A precision-guided missile doesn't just fly in a straight line, right?
No, it's tracking.
It is constantly adjusting its trajectory at supersonic speeds using tiny microactuators, sensors, and gyroscopes. Those tiny moving parts rely on RE-based magnets. Why? Because rare earth magnets retain their magnetic fields and conductive properties under extreme physical stress and massive temperature fluctuations. A normal magnet would demagnetize or literally melt under the heat of a jet engine or the friction of a missile launch. Rare earths don't.
So it's about stability under extreme duress. What about things like sonar and radar?
In electronics, it really comes down to signal processing and amplification. Certain rare earths are used to amplify optical signals in lasers and fiber optics. They enhance the sensitivity of sonar and radar arrays. In electronic warfare, if your radar is slightly less sensitive than your adversaries, or your communication equipment is slightly slower because you are using inferior conventional materials, you lose the engagement before you even see the enemy. Period.
It's the literal difference between hitting a target or missing it entirely.
Yeah. Exactly. That is why the text explicitly states that developing domestic RE capacity is essential for achieving strategic and technological superiority. It's not just a commercial industry. It is the absolute core of national security.
Okay, let's do a reality check here. We've laid out the vision. If these elements are the bedrock of the green transition, the absolute requirement for modern national security, and India has huge reserves in the ground, plus a massive 16,300 crore budget, why not just break ground tomorrow? What is actually stopping this from happening smoothly?
This brings us to the critical evaluation layer, what the source calls the rare earth dilemma. And the dilemma is that extracting these minerals might be one of the most environmentally destructive industrial processes on the planet.
Yes, the source mentions toxic waste generation contaminating air, water, and soil. And getting environmental clearances, especially adhering to coastal regulation zone norms, slows everything down. But honestly, mining is always dirty. Is this really that much worse than coal or copper?
It is exponentially worse. The true dilemma lies in the radioactive reality of these specific ores. And this is something people rarely talk about when they champion green energy.
This part of the source blew my mind. It notes that rare earth ores, especially the monazite sands found in India, are frequently laced with naturally occurring radioactive elements like thorium and uranium.
Right. Because of how they form geologically, rare earths and radioactive elements bond together in the Earth's crust. So when you dig up the rare earths and run them through those massive acid baths we talked about earlier, you are actively separating out radioactive thorium and uranium as a byproduct.
Wait, so the extraction isn't just dirty, it is legitimately generating radioactive sludge, and we are doing this to build wind turbines.
Yes.
I just have to point out the brutal irony here. We are actively pushing for toxic radioactive mining practices, generating radioactive lakes of wastewater, all to fuel our clean, green energy transition. How do policymakers even reconcile that?
This raises an important question, and it is an agonizing ethical and ecological paradox. Balancing that ecological safety with desperate economic and strategic needs is the single hardest part of the NCMM. The regulatory oversight required for safe radioactive waste disposal is immense, which makes the process incredibly slow and expensive. But the challenges aren't just environmental. The economic hurdles are massive.
Because even though they are called rare earths, they are actually abundant, right? They just aren't found in rich veins like gold.
Precisely. They are scattered thinly throughout the crust. You have to move and process mountains of earth to get a tiny yield. That means the upfront capital cost to build the mines and the chemical processing plants were astronomical, and it takes a massive amount of time to get them running.
The gestation period. The text notes that in India, establishing an integrated mining and processing infrastructure could potentially take 15 years before achieving substantial self-reliance.
15 years. Just think about that timeline for a second. That is a decade and a half of pouring billions of rupees into radioactive mud before you see a real return, or before you produce a single usable magnet. It severely tests the patience of private investors and the political will of governments.
And what happens in those 15 years? Technology changes, adversaries adapt. But let's say they do it. Let's say India pushes through the environmental hazards, waits the 15 years, and digs it up. The source points out something called the incompleteness problem, which means even if we dig it up, we still fail. How is that possible?
Because of where India's current capacity is stuck. Right now, India is mostly stuck upstream.
Hmm.
They can mine the ore, and they have some capacity to do the initial separation into rare earth oxides. But they lack the downstream industrial-scale facilities to take those oxides, turn them into specialized metal alloys, and then manufacture the high-tech permanent magnets and finished components.
So if you only do the upstream work, if you just mine it and do the basic separation.
You still have to put those intermediate materials on a ship and send them to China to be turned into the actual magnets,
Oh, wow.
which completely defeats the entire purpose of the 16,300 core mission. If you don't control the final steps of manufacturing the magnets, you remain entirely weak and dependent in the global value chain. That is why the PLI scheme for magnet manufacturing is the make-or-break linchpin of the whole policy.
It's incredible when you lay it all out like that. We are talking about a full-scale industrial revolution that has to be built from scratch, battling radioactive waste, a 15-year ticking clock, and an entrenched global monopoly that can crash prices at a moment's notice just to starve out new competitors.
And that is the scale of the challenge. India is attempting to shift from merely demonstrating capability to achieving true strategic autonomy. And doing that requires flawless execution across exploration, processing, manufacturing, and, environmental regulation.
So what does this all mean for you, listening to this briefing? It means the next time you see a headline about a government mandate pushing for electric vehicles, or you read about the development of new precision missiles or fighter jets, you shouldn't just think about the shiny end product. You are witnessing the front lines of an invisible, multi-billion-dollar supply chain war. India is attempting a massive, expensive, and environmentally fraught 15-year pivot just to secure the right to participate in the future.
Absolutely. And I want to leave you with a final thought to ponder. Looking at the sheer scale and the environmental cost of this entire endeavor, consider the reality of that 15-year wait time, the toxic acid baths, and the radioactive waste generated by mining new REs out of the ground.
Yeah.
Now weigh that against the 1,500 crore push for recycling we discussed. Could it be that the old phones, the broken laptops, and the obsolete hard drives sitting in your junk drawer right now aren't just trash? Given the staggering cost of pulling new metals from the earth, the contents of your junk drawer might actually be the most valuable untapped mines of our future.
It certainly makes you look at that phone in your hand a little differently, doesn't it? Thanks for joining us in the War Room for this deep dive. We'll catch you next time.